Hello and welcome back to my channel. My name is Piyush. This is day 52 in CK 2025 series, and in this video we'll be looking into storage class and dynamic volume provisioning using storage classes. So this video will be all about understanding it, how dynamic provisioning works, what is storage class, why do we use it, and all the nitty gritty around it. Plus, we'll be doing the demo in a GKE cluster, Google Kubernetes Engine cluster, because the dynamic provisioning needs a storage solution or a cloud provider that supports a storage solution. So that's why we'll be using GKE, but feel free to use AKS, EKS, or if you have a storage solution such as NFS, Portvox, VMware storage, anything that you like, but I'm just telling you what I'm using in this demo. So let me just share my screen, and first we'll go through the concept in detail, like what exactly it is, because before getting into the demo we need to understand a bit about it. Okay, I might have explained this a bit in one of the previous videos in the storage section where we discussed about persistent volume claims and so on, but I'm just gonna uh, maybe the demo was missing in that, so I'm just gonna explain it once again. So storage class defines how a is provisioned in Kubernetes, right? So when you create a storage, it has to be either statically provisioned or dynamic provisioning. So what exactly is a static provisioning? So for example, your storage admin, that person creates a persistent volume, and as a user, as a application developer, Kubernetes administrator, operator, DevOps engineer, like you can name any persona who's a user of the application, that person can create a persistent volume claim, and then the persistent volume claim will be bound to the persistent volume, and then later it can be utilized in the pod or your workload, right? So that's the static provisioning, in which you as a storage admin are pre-provisioning your persistent volume. Okay, so you are creating a persistent volume, and a PVC, which is a persistent volume claim, can request a slice from that persistent volume. Okay, so that's the static provisioning model. Now we have dynamic provisioning as well, in which we don't have to create the persistent volume. You create the persistent volume claim, give the storage class reference in the persistent volume claim, and then once the user requests a persistent volume claim, a PV will be created and it will be bounded to the PVC. Okay. Um, there are several use cases of why we use it. Because let's say the storage requirement differs from workload to workload, right? Some workload require, let's say, a high performance persistent disk. Some workload required an HSD for the cost effective method. Some storage required a balanced persistent disk, and so on, right? So we can create storage classes of all those persistent disks so that we don't have to pre-provision the persistent volumes, and it will help us save a lot of cost, and it will help us dynamically provision the volume when needed, and the volume will be deleted when it's not required. Okay, so that's the main difference between static and dynamic volume provisioning. Now it has different components, the storage class. So it defines what type of storage will be provisioned, right? Whether it is an NFS, SSD, HSD, HDD, and so many more. And how to create it. So there is a section in the storage class, it's called provisioner, and provisioner defines how do we create the storage. Okay, and then it has several configuration parameter, which is based on the performance, durability, stability, and which defines all those things, and it defines like how much cost effective or costly the solution is. Okay, now how it works. So this is the storage class. Okay, storage class has, as I've told you, it has provisioner, which defines how the storage will be provisioned. For example, whether it is AWS, EBS, Azure Files, GCP persistent disk, NFS, Portvox, or any other. So that is defined in the provisioner. And then these are the volume plugins. Okay, plugins as in it attaches the Kubernetes cluster to that respective cloud provider. For example, GCP, AWS, or Azure, and so on, right? So these are the volume plugins that is attached to the Kubernetes cluster, and it maps your Kubernetes cluster with the cloud provider so that the storage can be provisioned over there. Okay, so that's provisioner. Okay, and then we have parameters like the configuration parameters. We'll look at that once we do the demo. Then it has the reclaim policy, like what happens to the storage when the underlying persistent volume will be deleted. Okay, or when the underlying persistent volume claim will be deleted, what happens to the persistent volume? So that's part of reclaim policy. It could be deleted, it could be retained, recycle has been, I believe it has been deprecated, but now it is retain or deleted. Okay, and then it has several other options. Now the way it works is you create a storage class, and when user creates a persistent volume claim using the storage class, it creates a persistent volume, and then the persistent volume will be bounded to the persistent volume claim over here, right? Now let's look at the example, and let's look at the overall high level diagram of dynamic volume provisioning and static volume provisioning. So what happens in the static volume provisioning? Just give me a second, I might have. Okay, so how static provisioning works, this is something that we have discussed on a high level earlier. Let's have a look at that with the help of an example. So you create a persistent volume. Okay, like as a storage admin, you create a persistent volume with 80 gi of uh, storage, and the mode is read write once. Okay, so that's the mode is also part of storage, like your storage class as well as persistent volume. And then your developer, when developer wants to create an application, it creates a pod or a workload, then that person also create a persistent volume claim, let's say 10 gi, and the same mode as your PV is created, read write once. Okay, so this the storage, it should be less than or equal to what is available. Okay, that's one thing. Other is the mode should be same, so read write once, read write once. Once these things or these condition are matched, only then the PV will be bounded to the PVC. Okay, and this 10 GB, so we are requesting a slice from that persistent volume. So we have 80 GB of storage, out of that 10 GB we are taking and allocating it to the workload. So that's static provisioning. Okay, now what, okay, now there is dynamic provisioning as well, in which um, there is a developer who requests the persistent volume claim over here. Okay, let's say 70 gi, and this time the mode is rwx read write many. Now the persistent volume that we have over here, it has a different mode. Okay, and we don't have this particular PV already present. We don't have anything that has 70 gi of storage and rwx as the mode, storage mode, right? We don't have anything available, so this, we cannot bound this, right? It does not satisfy the requirement, even though the storage is similar 70 GB, but the mode is different, so we cannot use this one. Like, so what Kubernetes will do, based on the storage class that we have added in this PVC, it will create a new persistent volume with the same mode as this one. Okay, and it will bound it to that, and this will happen with the help of storage class, and this process is called dynamic volume provisioning. Okay, so this was static provisioning, this is dynamic volume provisioning. Over here we are creating the PV in advance, and a persistent volume claim will be attached to that PV, but over here we are not creating the PV in advance, or even the one that we had does not satisfy a requirement. That's why it will dynamically create a PV and bound that PV to the persistent volume claim. Okay, so we will be doing a demo, and in that demo we'll be creating two storage class, one for high performance and one that is cost effective. We'll be using the provisioner GC persistent disk, and the type of this will be PD SSD. The type of the other one will be PD standard, so that separate persistent volumes can be used. And this has a specific use case for high performance computing, and this is just for the dev test workload. Okay, So let me share my screen, and here it is. So I have a GKE cluster created. Now I'm gonna log into the cluster. So there are multiple ways. I have created multiple videos around GKE, so you can walk through that, or you can just simply follow what I'm doing right now. Okay, so I'm just gonna run that in the Cloud Shell, and it will help me log into the cluster. Let's do that. And while it's doing, let me pause the recording. It might take a couple of minutes. Okay, I have logged into the cluster. Now, what you can do is, let me just change the prompt. It's too huge. All right. Okay, now let's try to check the default storage classes that are available. Okay, so kubectl get storage class or SC. Okay, so we have three storage classes as you can see. First is premium RWO, that's the name. Second is standard. Third one is standard RWO. These are the provisioners. GCE PD and PDCSS storage, GKE IO. So they all are provisioner for GKE persistent disk or GKE, and it has different it has different what do you call a volume binding mode. Wait for first consumer or immediate, right? So wait for consumer means it will be bounded to the persistent volume, and persistent volume claim will be bounded once the pod that is requesting that storage is up and healthy. Okay, and immediate means the pod doesn't have to be there. Even if there is a PVC, PV will be bounded to that. Okay, now there is this default. So in front of the name, if it's written as default, that means that is the default storage class. So when you create a PVC without mentioning the storage class, it will by default be created as standard RWO. Okay, so now let's see if we can describe this. So kubectl describe storage class, name of the storage class. Okay, so what does it say? The provisioner is this, and parameter is this. Parameter has a type PD balance. That means by default PD persistent disk balance will be created. Okay, and there are some other options like mount option, reclaim policies, delete, and then there is annotation. Is default class is yes. That means that is the default storage class. Okay, you can also update the default storage class to something else. I'll show you how you can do that. Okay, so first let's begin with our demo. So first I'm gonna create two storage classes. One is for, let's say, high performance. So I'm just gonna paste the content. It's a kind is storage class. Okay, and its provisioner is GCE persistent disk. It will use PD SSD. These are the zones that it will be using, and replication type is regional. There are other details. Okay, so I'm just gonna save this, and kubectl apply hyphen f hp. Okay, it says created. So kubectl get storage class. Here is our storage class which says the name high performance. Okay, now let me try to create another one for our development workflow. Okay, so vi dev.yaml. Oops, vi dev.yaml. Okay, it has a different type. It uses PD standard. The other one was using balanced persistent disk, plus it was a regional persistent disk. So now we are only creating a zonal persistent disk in one zone, because that is a cost effective method that we are using, right? So kubectl apply hyphen f dev.yaml. Okay, so cost effective, high performance, both are storage classes have been created. Now let's change the default storage class with what it has to something else. So I'm gonna run kubectl patch command, and I'm gonna make the cost effective one as the default storage class. Okay, so kubectl patch storage class, name of the storage class, and this is the parameter. So we are changing in the annotation, we are changing storage class is true. Okay, now it's been patched, and if I do get storage class, now we can see cost effective is the default storage class. Okay, now let's try to create a persistent volume claim, and let's try to see how does it work. Okay, so pvc1.yaml. So it's a persistent volume claim, and access mode is read write once, which is matching with the storage class. Storage class name is high performance, and we are requesting 50 GI of storage. Okay, so kubectl apply -f pvc1 dot yaml. Okay, kubectl get pvc. Okay, it says pending, and if we do get pv, it has not been created yet. So let's wait. It should dynamically provision the persistent volume. Let's wait. Let's check if everything is good. Let's check if it is matching with the kubectl. Let's see. Get storage class. So we have created the one for production, and it says name is high performance. Uses okay, get pv again, nothing is there. Get pvc. Okay, it says pending. Storage class is high performance, and let's check this one more time. pvc1.yaml. Access mode is read write one. Storage is 50, and okay, storage class name is good as well. Okay, let's try to create another one as well, and let's see after this. So I'm gonna create one for the development environment as well. So pvc2.yaml, and over here I have not specified the storage class name so that it should use the default one. So kubectl apply -f pvc2 pvc2.yaml. kubectl get pvc. Okay, they both are pending, and we don't. Okay, so now dev storage is bounded, as you can see over here. Something wrong with the other one, I'll check that later on, but let's see the dev one. kubectl get pv. So it created a persistent volume. Okay, with the storage class as cost effective, because cost effective is now the default storage class once we passed it. Okay, and kubectl get pvc. Let's see why this is pending. Okay, so I'm gonna describe it. kubectl describe pvc. Okay, it says waiting for the first consumer to be created before binding. Okay, and because this is a first consumer one, right, and the one that we've created earlier, get pvc. Let's see this one. If I describe this one, kubectl describe pvc dev app storage, it says waiting for the volume to be created. That's okay. And succeeded, and its volume mode is, let's see, I'm gonna compare the storage class YAMLs for both. So cat HP, which is high performance over here, volume binding mode is wait for first consumer, and if I do dev one, volume binding mode is immediate. That is why it did not provision it. It was waiting for the pod to be provisioned first. So let's change the one. Let's change the HP one, and let's change the volume binding mode to immediate, or you can create a pod and consume the volume. That's one and the same thing. Okay, and now let's apply the changes. Is invalid. Oh, okay, field is immutable, it cannot be changed, so I have to delete it and then apply it again. Okay, delete and then apply it again. Okay, if I do kubectl get pv, okay, still not created. Let's wait for it. Still pending. Kubectl, oh, it did not created, it did not deleted the pvc actually. So let's delete the pvc first. Kubectl delete pvc. Okay, and vi pvc1. Over here everything is good. Let's try to provision this again. Kubectl apply -f pvc1. Okay, kubectl get pvc. Still pending. Now it's bound. Okay, it says it's bound, and if I do kubectl get pv, so you will see it has created another storage as well over here. So we have two storage because I have created it twice. I have not deleted the other one, and the reason over here is retain. That means when I deleted the earlier one, it was already bounded and it retained it. Okay, and now when I created the pvc again, it created a new pv. So that's what I wanted you to see. So we have covered both the scenarios. We have covered all from the exam perspective as well, and all the fundamentals of PVC storage class. So yeah, that's it for this video. I'm gonna just clean up my cluster now. Make sure you delete the cluster once you are done, otherwise it will cost you a lot of money. So thank you so much. I will see you soon with the next one, and you have a good day. Happy learning.